Hello everyone, welcome to our CET online class. In this video, we will discuss Units and Measurements chapter of class 11. Let us start with the synopsis. The very first concept of this chapter is a physical quantity. So what is a physical quantity? A quantity which can be measured directly or indirectly is called a physical quantity, which means a quantity which can be measured and expressed in terms of numbers. For example, mass of an object can be measured and expressed as a 12 kg. Similarly, length of an object, velocity and acceleration are the examples for physical quantity. These also can be measured and expressed in terms of numbers. Measurement of a physical quantity. A physical quantity can be measured by comparing it with another homogeneous quantity of some kind which is taken as a standard. This standard finds out how many times the given standard is contained in the physical quantity. So this standard is nothing but a unit. So unit is a standard in terms of which a physical quantity is measured. For example, say mass of an object is 100 kg, which means the mass is 100 times the unit kg. Choice of standard unit. So we have to choose a standard unit depending on certain conditions. Let us see them one by one. The unit chosen should be accepted internationally. It means there must be no confusion between the nations in order of usage of a unit. Second one, the unit should be accurately defined and it should be meaningful. Third one, a unit must be convenient in order to use it. Fourth one, the unit must be easily reproducible or it can be easily copied. Fifth one, a unit should not change with respect to time. It means it should remain constant with respect to time. Next one, a unit must be imperishable, which means a unit should be not be temporary. It should be permanent. Last one is a unit should not change with respect to physical conditions like temperature, pressure, which means a unit must be independent of physical conditions. A body named General Conference on Weights and Measures was set up and given authority to decide the units by international agreement. This body holds meetings and any changes in standard units are communicated through the publications of the conference. This body sets a defined system of units. There are several systems of units. Let us understand them one by one. First one is FPS system. This system is a British engineering system. This system uses foot as unit of length, pound as unit of mass and second as unit of time. Second one is CGS system. CGS system is a Gaussian system which uses centimeter, gram and second as the three basic units for length, mass and time respectively. The third system of unit is MKS system. This system is based on meter, kilogram and second as fundamental units for length, mass and time. The last one is International System of Units, or it is also called as SI system. This system of units is a modification over the MKS system and hence it is also called as rationalized MKS system. We have to define a system in International System of Units. The units which are used all over the world are defined under SI system. Now let us understand fundamental and derived units. Before that, we must know what are fundamental and derived physical quantities. A fundamental quantity is one which is independent of all the other physical quantities, which means it is defined independently. A derived physical quantity is one which is dependent on fundamental physical quantities. With nothing but a derived physical quantity is derived from a fundamental physical quantity. So there are three physical quantities, namely mass, length and time, which are called fundamental units. Fundamental units are one given for a fundamental physical quantity. These units are defined independently. A derived unit is one which are given for derived physical quantity and these are derived from fundamental units. The units which are derived from these units are called derived units. In addition to these two, there are two supplementary quantities. Those are plane angle and solid angle. What is plane angle? It is the angle between two intersecting straight lines measured in the plane of same lines. The plane angle is a dimensionless physical quantity measured in degree or radian. Second one is solid angle. A solid angle is a three-dimensional angle subtended by any object at a certain point in three-dimensional space. The SI is based on 7 fundamental units and 2 supplementary units. Those are look at the table. Now understand the basic physical quantity and its fundamental unit and the symbol used for the fundamental unit. Mass is the basic physical quantity. The unit is kilogram given to it. The symbol given is kg. Length is the another quantity. Meter is the unit given for it. Small m is the symbol given to it. Time is the another physical quantity. Second is its unit and S is the symbol. Similarly, temperature, electric current, luminous intensity and quantity of matter. These are the 7 basic physical quantities which are independent of all the other physical quantities. The fundamental units are 7. Those are kilogram for mass, meter for length, second for time, Kelvin for temperature, ampere for electric current, candela for luminous intensity and mole for the quantity of matter. These are the 7 fundamental physical quantities and their units. Let us look into the supplementary units. The one is plane angle, which is present in the two-dimensional space. The unit for this is radian, which is an SI unit, and the symbol is RAD. The second one is solid angle. The unit given for this is steradian and the symbol is SR. Solid angle is the angle situated in the three-dimensional space. The units of measurement of all other physical quantities which can be obtained from fundamental units are called derived units. For example, Newton is the derived unit which is derived from mass, kilogram and second. Newton is the SI unit of force. Hence, force is also a derived physical quantity. The three basic units are length, mass and time. Here we are measuring length, mass and time. Now let us see the measurement of length. Length is the distance between 2 points. Here we have categorized length into measurement of smaller length and measurement of larger distances. Firstly, measurement of smaller lengths can be made using the instruments meter scale, vernier calipers and screw gauge with their accuracies. Meter scale is having an accuracy of 10 raised to minus 3 to 10 raised to 2 meter. Vernier calipers is having an accuracy of 10 raised to minus 4 meter and screw gauge is having an accuracy of 10 raised to minus 5 meter. The larger distances can be measured using parallax method. Measurement of mass. Mass is the quantity of matter in a body. It is the basic property of matter defined independently. The ranges of masses of objects in this universe lie between 10 raised to minus 30 kg to the 10 raised to minus 55 kg. 10 raised to minus 30 kg is the least possible value, which is the mass of an electron, and 10 raised to 55 kg is the mass of an universe. Masses of microscopic objects means the objects which are invisible to our eyes. These masses can be determined by spectroscopic methods. The masses of astronomical units are estimated by Newton's law of gravitation and Kepler's law of time periods. The microscopic masses are defined using an unit, atomic mass unit. What is this atomic mass unit? It is nothing but the 1/12th mass of an carbon 12 atom, which is equals to 1.66 into 10 raised to minus 27. Measurement of time. A clock is used for the measurement of time. Any phenomena that repeats itself can serve as a clock. The synchronous rotation of a motor on alternating current or the variations in pressure across courge phases are also considered as the measurement of time. Accuracy and precision. The most important concept of this chapter are accuracy and precision. So what is accuracy? Before that, we must know what are true value and measured value. So true value is nothing but the actual value of a physical quantity. Measured value is the one which is measured through an instrument. So accuracy means the closeness of the measured value to the true value of the physical quantity is known as accuracy. If the true value and measured value are close enough, then we say that the more accurate is the value. Now let us understand what is precision. It is defined as the extent or the limit to which the measurement of a physical quantity is done, which means a physical quantity measurement is equals to the least count of the instrument with which the measurement is made. Errors in the measurements. While measuring any physical quantity, there are uncertainties. So these uncertainties are defined as the error. It is nothing but the difference between measured value and true value of a physical quantity. The errors are classified into three categories. Those are constant error, systematic error and random error. What is constant error? If the same error is repeated every time in an observation, then it is called as constant error. Systematic errors are those which occur in a regular pattern. These systematic errors are due to known reasons and they can be minimized by locating the source of error. Again, systematic errors are classified as instrumental error, personal error and natural error. The instrumental error is caused due to the faulty design in the instrument. The personal error is nothing but the error due to the limitations or carelessness of an observer. These errors are occurred by an person who is performing the instrument experiment. Natural error is the one which arises due to the change in the conditions like temperature, pressure, etc. The natural error is dependent on the nature's conditions and physical conditions. What is random error? The errors which are unknown and occur in a random manner are called random errors. These errors cannot be controlled by the observer. Other than these errors, there are three errors which are absolute error, relative error and percentage error. Absolute error is the magnitude difference between measured value and true value. Relative error is nothing but the ratio of mean absolute error to the mean value of a quantity. Percentage error means if the relative error is expressed in terms of percentage, then it is defined as percentage error. Now let us understand what are significant figures. A significant figure is nothing but which expresses the accuracy with a physical quantity may be expressed. The digits whose value are accurately known in a particular measurement are called significant figures. Example, a figure 1.21 means the quantity can be relied on as accurate to 3 significant figures. Thus, significant figures in a measured quantity indicate number of digits in which we have confidence, in which we are accurate to express. There are certain rules defined for significant figures. Those are all non-zero digits are significant. The zeros between non-zero digits are also considered as significant figures. The leading zeros left to the first non-zero digits are not significant. For example, 0.001 has only one significant figure. The terminal zeros in a number without a decimal point are also not considered as significant figures. Last one is the terminal zeros that are to the right side of a decimal point are considered as significant figures. Rounding of figures. If the digit is dropped in a number is less than 5, then the preceding digit remains unchanged. Similarly, if the digit to be dropped in a number is greater than 5, then the preceding digit is raised by 1. For example, consider the number 8.66. The last one is greater than 5 and hence it is raised to 1 and hence it becomes 8.7. Similarly, if the digit to be dropped in a number is 5, then the preceding digit remains unchanged if it is even and it is raised by 1 if it is odd. The most main concept of this chapter is dimension. So what is dimension? What are dimensions? These are the powers to which the fundamental quantities must be raised to obtain the quantity. For example, we say that area has 2 dimensions in length. The dimensional formula of any physical quantity represents or explains its relations with the fundamental quantity. Let us learn the dimensions of base quantities. The length is given as capital L, m is given for the quantity mass, the time is represented as capital T, current is represented as capital A as its dimension, temperature is given as capital K, luminous intensity is given by small cd, amount of substance is given by mole in small letters. All the dimensional formulas are written in the square bracket. In mechanics, all the physical quantities can be expressed in terms of the dimensions m, l and t. Applications of the dimensional analysis. So what is dimensional analysis? The process of examination of dimensions of various physical quantities is called dimensional analysis. There are two applications. One is principle of homogeneity and dimensional analysis. So dimensional analysis helps us to convert unit of a physical quantity from one system to another. For example, we can convert a unit of force, that is Newton. We can convert Newton from SI unit to CGS system. The second one is using dimensional analysis we can check the correctness of an equation. We can examine whether the given equation is dimensionally correct or not. Third one is we can derive a relation between two physical quantities using dimensional analysis. Let us understand what is principle of homogeneity. The principle of homogeneity states that the dimensions of all terms in a physical relation or in a equation on either side must be same. For example, if we are considering an equation, then the dimensions on LHS and RHS must be same, which means the magnitude of physical quantities of similar nature can be added, subtracted or compared with one another. This is called Fourier's principle of homogeneity. This is the completion of synopsis of the chapter Units and Dimensions. Thank you.
So let us start with the questions. If unit of length and force are increased by 4 times, the unit of energy is. So here you have to find out the energy which is increased. Hence the relation between length, force and energy is given by W is equals to force into displacement. So W means work done, or you can also call it as energy required to do a work. F is the force and S is the displacement or the length covered by the object. So here the length is increased by 4 times, that is 4S, and the force is also increased by 4 times, hence F becomes 4F. So the energy becomes 4 into 4, that is 16 F into S. So hence the energy required is increased by 16 times. So the right answer is option B. So if you increase length and force by 4 times, then the increase in energy is given by 16 times. So let us move to the next question. The density of a material in CGS system of units is 4 gram per centimeter cube. In a system of units in which unit of length is 10 centimeter and unit of mass is 100 gram, then the value of density of material will be. So here the given values are length is increased by 10 centimeter and mass is increased by 100. So there is a unit, so that is in the CGS system the density is given by mass by volume. The mass is in gram and the volume is in centimeter cube, isn't it? So now there is a system in which the length is increased by 10 centimeter and the unit of mass is increased by 100. So if you increase the length and mass values, then obviously the value of density also changes. So how much will be the change? Let us find out. So the density is equals to, what is the density given here? The given density is 4. 4 gram by centimeter cube, isn't it? Now in this system the mass is increased by 100 and length is increased by 10. So 4 into 100 whole divided by 100 gram divided by the volume is 10 by 10 whole raised to 3 centimeter cube. So you must be thinking how this 10 raised to 3 has arrived. So observe here, if the length of the object is given by 10 centimeter, it means it is increased by 10, then the volume becomes 10 raised to 3. You know that volume is equals to length into breadth into height. So volume becomes 10 into 10 into 10. So volume is equals to 10 raised to 3 centimeter cube. So the density is 4 gram per centimeter cube. So the mass is increased by 100. So 100 by 100 into gram divided by 10 raised to 3. So if you get cancel these two values, again you will get this 4 gram per centimeter cube. So now we are defining a new system here. Here rho density is equals to 4 divided by 100 gram whole divided by 1 by 10 raised to 3 centimeter cube. Now the new system is increased by 100 gram divided by 10 raised to 3 centimeter cube. Now simplify this value. What it becomes? 4 divided by 100 into 10 raised to 3. So 10 raised to, this is 100 nothing but 10 raised to 2. This get cancels with 10 raised to 3. The remaining is 10. So the density value becomes 40. If you increase the length by 100 centimeter and mass by 100 gram, then the density becomes equals to 40 times. This is the new unit we have defined here. Okay, is it clear? So the next question is, resistance R is equals to V by I. Here V is equals to 100 plus or minus 5 volt and current I is equals to 10 plus or minus 0.2 ampere. Now find the percentage error in R. So the given values are R is equals to V by I. So remember, if a physical quantity is given in terms of product or ratio, then you have to apply the formula for percentage error, that is delta Z divided by Z is equals to delta A by A plus delta B by B. Here Z is nothing but ratio of A and B. So you have studied this in the theoretical part in the chapter units and measurements. So you have to apply this formula to find out the percentage error. So this ratio delta Z by Z is nothing but the relative error. So here we are going to find the percentage error. To find out the percentage error, so percentage error is nothing but relative error into 100. So if you multiply this value with 100, so you will get the percentage error. Now we have to find the percentage error. For that we have to first determine the relative error. So given R, V is equals to 100 plus or minus 5 volt and I is equals to 10 plus or minus 0.2 ampere. Now apply the formula. So this is the value of I plus or minus delta I. This is the value of I. This is the error in the I. Here V plus or minus delta V. So delta V is 5, error in the measurement. Now delta Z by Z becomes delta R by R, that is equals to delta A by A. So here A is nothing but volt, B is nothing but current. So delta A means delta V by V plus delta I by I. So delta V value is 5 divided by V value is 100 plus delta I value is 0.2 divided by 10. Now simplify this. So you will get the answer 0.05 plus 0.02. Now the final answer is 0.07. So this is the percentage error, that is equals to 0.07. Now we have to find the percentage error. Sorry, this is the relative error. Now substitute relative error is 0.07 into 100. So percentage error is 0.07 into 100, that is nothing but 7%. So option C is the right answer. Is it clear? Now next question. Find the equivalent resistance when R1 is equals to 100 plus or minus 3 ohm and R2 is equals to 200 plus or minus 4 ohm when connected in series. So there are two resistors which are in series connection. So this is R1 and this is R2. The value of R1 is 100 plus or minus 3 ohm and R2 value is 200 plus or minus 4 ohm. Now you have to find the equivalent resistance. So for this you already know the R equivalent is equals to R1 plus R2. Now So R1 value is 100 plus or minus 3 plus R2 value is 200 plus or minus 4. For determination of error, if the Z is A plus B, it means the physical quantity is sum of 2, then the delta Z is equals to delta A plus delta B. Now, for this, delta A value is 3 plus delta B value is 4. So the error here is 7. And R1 plus R2 becomes nothing but 300, and the error in the equivalent resistance is 7. So option A is the right answer. Next question. In an experiment, 4 quantities A, B, C and D are measured with percentage error 1%, 2%, 3% and 4% respectively. So the quantity is calculated as P is equals to A cube into B raised to 2 divided by CD. So find the percentage error in P. Here P is given as A cube B square divided by CD. So this is the physical quantity given, and another values given are delta A by A into 100, delta B by B into 100, delta C by C into 100 and delta D by D into 100. All the values are given. So percentage error means relative error into 100. So this value becomes 1. It is given. Okay. So percentage error in A is 1%, in B is 2% and in C is 3% and D value is 4%. Now we have to find the percentage error of this quantity P. So P is denoted as A cube B square divided by CD. So if the power value is given, so here A raised to 3 is there, here B square is there. So if such value is given, then the percentage error becomes 3 into delta A by A plus 2 into delta B by B. Okay, and it is the ratio of CD, isn't it? So plus delta C by C plus delta D by D. So this is the formula to find out the relative error in P. So the formula becomes delta P by P, that is relative error, is equals to 3 into delta A by A plus 2 into delta B by B plus delta C by C plus delta D by D. So this is the relative error. To find the relative error, we have used this formula. To find the percentage error, we have to multiply this by 100. Okay. So this becomes 3 into delta A by A into 100, so on. So it means we are finding the percentage error, isn't it? So delta P by P into 100 equals to 3 into percentage error in A, percentage error of A plus 2 into percentage error of B plus percentage error of C and plus percentage error of D. So the given values are percentage error of A is 1, so 3 into 1 plus 2 into percentage error in B is 2 plus percentage error in C is 3 and of D is 4. Now simplify this. So what is the final answer? 3 plus 4 plus 3 plus 4. So what it becomes? 14, isn't it? 14%. So the answer is option D. Okay. So the next question is, in a vernier calipers, n division of vernier coincide with n minus 1 divisions on main scale, in which length of a division is 1 millimeter. The least count of the instrument in centimeter is. Okay, read the question carefully and then find out the formula related to that and then substitute and solve. This is the method to solve a CET question. So first you have to read the given value. So the given value is value of 1 MSD. Okay. So the value of 1 MSD is 1 millimeter. So you already know that vernier calipers consist of two scale. One is main scale and another one is vernier scale. Okay. So the vernier scale and main scale are the two scales of vernier calipers. Here the main scale is measured in centimeter and there are 10 divisions on the vernier scale. Here the given is n divisions coincide with the n minus 1 divisions on main scale. So in vernier calipers, n divisions of vernier scale. So here the n divisions on vernier scale coincide with the n minus 1 divisions of main scale. Okay, this is vernier scale and this is main scale. So find out the least count. For this least count formula, LC is given by, you already done the practicals. So LC is equals to value of 1 MSD divided by total number of VSD. Total number of VSD, isn't it? Now observe here, the value of 1 MSD is not 1 centimeter. Already you know that the value of 1 MSD is 1 centimeter. But here there is a difference, that is the value of 1 MSD is 1 millimeter. So substitute 1 millimeter divided by total number of VSD. So they have given that there are totally n number of vernier scale divisions coincide with the n minus 1 main scale divisions. So substitute the total number of VSD, so vernier scale divisions are n. Now it becomes 1 by n millimeter. So this is the LC of vernier calipers. Now the answer is, we have to write it in centimeter. So convert this in centimeter, 1 by n. So centimeter we have to divide it by 10, isn't it? Divide it by 10. So what is the final answer? 1 by 10 n centimeter. So least count of this vernier calipers, where one division value is 1 millimeter, becomes 1 by 10 n. So this answer is option C. Next question. The refractive index of water measured by the relation mu is equals to real depth by apparent depth is found to have values of 1.34, 1.38, 1.32, 1.36. The mean value of refractive index with the percentage error is. So read the question. What are the given values? We have measured the refractive index of water given by mu. So we have measured the four values: 1.34, 1.38, 1.32 and 1.36. These are the measured values. So now we have to find the percentage error. So for percentage error, what is the formula? Delta mu divided by mu into 100. So this is the formula for percentage error. So here first we have to determine delta mu and then we have to find out the value of mu. So here delta mu is the error and mu is the average value. So how you have to find the mu value? Mu is equals to average value means if this is x1, x2, x3, x4. So to find the mean value you have to add all of these four values and then divide it by 4. So now to find the mean value of mu I am going to add all the four values: 1.34 plus 1.38 plus 1.32 plus 1.36 whole divided by 4. So this value becomes 1.35. Now this is the value of mu. Now find the value of delta mu. So already we know that the formula for mu is delta mu is nothing but absolute error in the mu. Okay. So absolute error is given by x1 minus x min. Here delta mu is the absolute error. So absolute error is nothing but it is the difference between individual measurement and the mean value. Here individual measurements are these values. Now individual measurements minus the mean value. Okay, you have to take the magnitude. According to definition, it is nothing but the magnitude of difference between individual measurements and the mean value. Delta mu is nothing but the difference between individual measurements and the mean value. For this we have to take the individual measurements and difference with respect to their mean value. So what it becomes? 1.34 minus 1.35 plus 1.38 minus 1.35 plus 1.32 minus 1.35 plus 1.36 minus 1.35. You have to divide it by 4 because there are 4 values. So substitute the values and simplify this. So delta mu value becomes 0.02. Already we know that mu is nothing but 1.35. Now to find the percentage error, delta mu by mu into 100. So delta mu value is 0.02 divided by mu is 1.35 into 100. So simplify this, you will get the answer 1.48. 1.48, it means option A is the right answer. Next question. A wire has a mass of 0.3 plus or minus 0.003 gram radius 0.5 plus or minus 0.005 millimeter, and length 6 plus or minus 0.6 centimeter. Find the maximum percentage error in the measurement of its density. We have to find the percentage error in the density. So percentage error means delta rho by rho into 100. For this we must know the relationship between mass, radius and length of the wire. So these are the values given. We have to convert the density in terms of mass, radius and length. So what is the formula for rho? We know that rho is equals to mass divided by volume. So mass is as it is. So the volume of the wire. So wire is having a cross sectional area like this circle. The cross sectional area of the wire is circle, which is having the radius r, and the length of this wire is say L. The wire is having cross sectional area of a circle, isn't it? So what is the area of a circle? Area is equals to pi r square. We already know that. And length of the wire is L. So volume is equals to area into length. Area is pi r square L. So the volume of the wire is pi r square L. Is it clear? This is the relationship between mass, radius, length and density. Now write the formula for percentage error. It is the ratio of mass and pi r square L. Here pi is the constant, so we are going to neglect it. So what will be the formula for percentage error in density? Mass means delta m by m into 100 plus r square L. So for this 2 delta r divided by r plus L means delta L divided by L into 100, because the given values are in percentage error. So the formula for percentage error in density is delta rho by rho into 100 becomes delta m by m into 100 plus 2 into delta r by r into 100, length delta L by L into 100. So substitute the values here. Delta m by m into 100 is nothing but 0.003 divided by m means 0.3 into 100 plus 2. Delta r value is 0.005 divided by r value is 0.5. I think you know that this is r plus or minus delta r. This is m plus or minus delta m, and this is L and this is delta L. So it is given like this, A plus or minus delta A. So all the quantities are in this form. So here delta M means 0.003 divided by 0.3 plus 2 into delta R value is 0.005 divided by 0.5. Multiply this by 100. Okay, into 100 plus last delta L is 0.06 divided by 6 into 100. Okay, so simplify this value. What you will get? The final answer is 4. So the correct answer is option D. Next question. 1 centimeter on the main scale of a vernier calipers is divided into 10 equal parts. If 10 divisions of vernier coincide with the 8 small divisions on main scale, the least count of vernier calipers is. Here the vernier calipers is having main scale and vernier scale. The given data is 1 centimeter on main scale. So 1 centimeter on main scale is divided into 10 equal parts. So it means the value of 1 MSD becomes 0.1 centimeter. If 10 divisions on vernier scale coincide with 8 small divisions on the main scale, it is given that 10 vernier scale divisions coincide with 8 main scale division. So what will be the LC of the vernier calipers? Value of 1 MSD is what? Value of 1 MSD is, we know that it is 0.1. So the value of 1 MSD we have to find. So for this we know that 10 VSD is equals to 8 MSD. It means 10 vernier divisions coincide with the 8 main scale divisions. So the value of 1 vernier scale divisions becomes 8 by 10 and value of 1 MSD is 0.1. Simplify this, you will get the answer 0.08 centimeter. So the value of 1 vernier scale division is 0.08 and the value of 1 main scale division is 0.1 centimeter. Now the LC of vernier calipers is found by subtracting these two values. So value of 1 MSD minus value of 1 VSD. So the value of 1 MSD is 0.1 minus 1 VSD is 0.08. So subtract these values, you will get 0.02 centimeter. So option B is the right answer. Next question. The pitch of the screw gauge is 0.5 millimeter. Its circular scale contains 50 divisions. The least count of the screw gauge is. So already we have done practicals on the screw gauge. So in that screw gauge we have seen there are 100 divisions. But here it is given that there are 50 divisions on the circular scale. Here circular scale is nothing but the head scale. So which rotates, that is nothing but head scale. Here circular scale means nothing but head scale. Pitch of the screw gauge is 0.5 millimeter. So the pitch is given 0.5 millimeter and total number of head scale divisions. Head scale divisions are 50. We have to find the least count. So for the formula of least count of the screw gauge, we write it as pitch divided by total number of head scale divisions, isn't it? So the pitch is 0.5 whole divided by total number of head scale divisions are 50. So this becomes 0.01 millimeter. The answer is option B. Next question. Relative density of a material may be found with the help of spring balance. In air, the spring balance reads 5 plus or minus 0.05 Newton and in water it reads 4 plus or minus 0.05 Newton. Percentage error would be. So here it is given that the relative density of a metal is measured in air as well as water. Now we have to determine the percentage error. So the relative density is given by relative density is equals to weight of wire in air divided by loss of weight in water. Okay, so this is the relative density. Now weight of the wire in air is 5 divided by loss of weight in water. So in water it reads 4 and in air it reads 5. So the loss is 5 minus 4. So the relative density becomes 5 by 1.00. That is equals to 5.000. This is the final value of relative density. Now the percentage error. Percentage error is equals to delta rho by rho into 100. Here rho means relative density, not usual normal density. So this is found using these two values, the relative density in air and in water. So in air delta value is 0.05 divided by 5.00 plus in water it is 0.05 divided by 4.00 into 100. So simplify this, you will get 0.06 into 100. So that is equals to 6%. So the percentage error in relative density is 6% here. So the option D is the correct answer. A force F is applied onto a square plate of side L. If the percentage error in determining L is 2% and that in F is 4%, the permissible percentage error in pressure is. So you have to find the percentage error in pressure. So the pressure is given by P is equals to F divided by A. Pressure is nothing but force divided by area. So F, what is the area of a square of side L? So this is the square of side L. Area becomes square of this side. So area is L square. So pressure is nothing but force divided by L square. Now write the formula for percentage error in T, pressure. So delta P by P into 100 equals to delta F by F plus 2, because the power of L is 2. 2 into delta L by L into 100. Okay, this 100 is for both the terms. The percentage error in F is 4 and length is 2. So percentage error is 4. It means delta F by F into 100 is 4 plus 2 into delta L by L into 100 is 2. Okay, 2 into 2. So simplify, you will get the answer 8%. Okay, so the answer is option D. Next one. The period of oscillation of a simple pendulum is given by T is equals to 2n root of L by G. Measured value of L is 20 centimeter, known to 1 millimeter accuracy, and time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of resolution 1 second. The accuracy in the measurement of G is. Okay, so see the options. The options are in percent. Hence, the accuracy means you have to find the percentage error in the G value, that is delta G by G into 100. So we have to find the percentage error in the G value. So what is the expression? So it is given that T is equals to 2 pi square root of L divided by G. Okay, square this on both sides, you will get T square is equals to 4 pi square L by G. So G becomes, G is equals to 4 pi square L divided by T square. Okay, 4 pi square is the constant value, leave it. Now write the percentage error formula for this. Delta G by G into 100 becomes delta L by L into 100 plus 2, because the power of T is 2. Okay, 2 into delta T by T into 100. So it is given that the delta value of L, so delta L is given. What is the value? 1 millimeter. Okay, convert it into centimeter, it becomes 0.1 divided by length L is 20, it is given 20 centimeter into 100 plus 2 into, so delta T, that is minimum value, that is the delta T value. So what is the minimum value? 1 second. So 2 into 1 divided by the time required for the whole process, that is 400 oscillation is 90 seconds. So time is 90 into 100. So simplify this, you will get the answer 2.72. So this 2.72 is nearly equals to 3%, isn't it? So the option is D. D is the correct answer. In a simple pendulum experiment, the maximum percentage error in the measurement of length is 2%, and that in the observation of time period is 3%. Then the maximum percentage error in the determination of acceleration due to gravity. So again, you have to find the delta G divided by G into 100. So read the question carefully. It is given that the percentage error in length is 2% and time period percentage error is 3. Find the value of percentage error in G. So already we know that delta G by G into 100 is equals to delta L by L into 100 plus 2 delta T by T into 100. So this value is 2 plus delta T by T into 100 is 3. So 2 into 3. So the final answer is 8%. So the option D is the answer. Diameter of a steel ball is measured using a vernier calipers, which has divisions of 0.1 centimeter on its main scale and 10 divisions on its vernier scale, matches 9 divisions on the main scale. 3 such measurements for the ball are given below. So the main scale readings are 0.5 and VS divisions are 8, 4 and 6. If the zero error is minus 0.03 centimeter, then mean corrected diameter is. So here the given data is value of 1 MST equals to 0.1 centimeter. Total number of VST are 10. 10 VST coincide with the 9 MSD, that is 10 vernier scale divisions coincide with the 9 main scale division MSD. Now we have to determine the mean corrected diameter. For this there are 3 values we have. Before that we have to find the least count. So least count is equals to value of 1 MST divided by total number of VST. So value of 1 MST is 0.1 divided by total number of VST are 10. So this becomes 0.01 centimeter. The LC of vernier calipers is 0.01 centimeter. You have to find the value, that is using the formula TR is equals to MSR plus CVD into LC. You have already done this in your practicals. For first trial, MSR is 0.5, CVD is 8 and LC is 0.01. So the total reading for this value is 0.5 plus 0.08. So it becomes 0.58. So the total reading is 0.58. So for this reading is 0.54. For this trial 0.56. So these are the three values, total readings taken for the measurement of the diameter of this steel ball. Now we have to find the mean diameter. Mean diameter is equals to, add all the three values, 0.58 plus 0.54 plus 0.56 whole divided by 3, because there are three trials. Mean diameter is 0.56 centimeter. The corrected diameter is mean diameter minus 0 error. Okay, I think you remember in your practicals you have measured the mean corrected diameter by subtracting the mean diameter with the 0 error. So already the 0 error is given. What is the 0 error? Minus 0.03. Mean diameter is 0.56 minus 0 error is minus 0.03. So the final answer becomes 0.59. So minus into minus becomes plus, 0.56 plus 0.03 becomes 0.59 centimeter. So the answer for this question is option B. Next one, the respective number of significant figures for the number 23.023, 0.0003 and 2.1 into 10 raised to minus 3 are respectively. So here we have to find the significant figures in the given three numbers. So the numbers are 23.023 and 0003, 2.1 into 10 raised to minus 3. So you already know the rules to write the significant figures. So here the decimal value having 5 significant figures, isn't it? So number of significant figures in first is 5. The second number is having significant figure only 1. Why? Because preceding zeros in a decimal number are not significant. I hope you remember the rules for writing the significant figures. The preceding zeros in a decimal value which is less than 1 are not significant, and in the third number the significant figures are only 2, because you should not consider this scientific notation. So there are only 2 significant figures in the third one. So 5, 1 and 2, option A is the right answer. Next one, the value of resistance is 10.845 ohm and the value of current is 3.23 ampere. The potential difference is 35.02935 volt. Its value in significant number would be, the relation between volt and current with respect to resistance is V is equals to I, Ohm's law. We already know that if there is a product, current value is 3.23 into resistance is 10.845 and B becomes 35.02935 volts. Okay, so if the given number is a product of two significant figures, here potential difference is the product of current and resistance, isn't it? So if such quantity is given, so you have to write the answer in terms of the least significant figures of these two. So here I, R. Which one is having the least significant figures? Current. So how many significant figures are there? 3.23. Current is having only 3 significant figures. So we must also write it as 35.0 volt, which is having only 3 significant figures. It means the result must be in the least significant figures in the two numbers of I and R. So the answer is option B. So next question. Mass of a body is 210 gram and its density is 7.981 gram per centimeter cube. What will be its volume with regard to significant figures? So we know that mass, density and volume relation, that is rho is equals to m by v. Density is equals to mass by volume. So the given is 210 mass and volume we have to find. Okay, volume is 210 divided by density. Density is 7.981. The answer for this is 26.312. But we have to write with respect to the significant digits. Now I have already discussed that if the given number is product or ratio, then you have to write it in terms of the least significance of these two values. If this mass value is having only 2 significant digits, isn't it? The last digit is not significant according to the rules. So there are only 2 significant digits. So we must also express in only 2 significant digits. That is B is equals to 26 centimeter cube. This is the answer. So option B is the right answer. Next one. A force is given by F is equals to AT plus BT square, where T is time, the dimension of A and B are. The given is F is equals to AT plus BT square. According to the principle of homogeneity, the terms on both the sides are equal. The dimensions of F, AT, BT square are equal, isn't it? According to the principle of homogeneity. So now F is equals to AT. Now we have to find the dimension of A and dimension of B. So first consider these two. F is equals to AT. The dimension formula for force is M L T raised to minus 2 equals to AT. Now the dimension of A becomes M L T raised to minus 2 whole divided by T. This becomes M L T raised to minus 3. So this is the dimension of A. Now similarly, dimension of F equals to BT square. B equals to, the dimensional formula for F is ML T raised to minus 2 whole divided by T square becomes like this. Simplification, ML T raised to minus 4. The correct answer is option C. The next question is, the frequency of vibration of a string is given by F is equals to N divided by 2L into the square root of T divided by M, where T is tension in the string, L is the length. The dimensional formula for M is given is that F is equals to N divided by 2L into the square root of T divided by M. So this is the given formula. Now we have to determine the dimensional formula for M. Squaring on both sides becomes F square is equals to N square divided by 4L square into T by M. Now let us take the expression for M. M is equals to N square divided by 4L square F square into T. Now substitute the dimensions for all the terms. What it becomes? M is equals to, so N is a number of harmonics, it is a constant. 4 is also constant. Here L is the length, so dimension for length is L, so it is square, it becomes L square. And the dimension for frequency is T raised to minus 1 whole square into tension is nothing but ML T raised to minus 2. Simplify this. ML T raised to minus 2 divided by L square T raised to minus 2 M L raised to minus 1 T raised to 0. So this is nothing but ML raised to minus 1. Next question. Which of the following pairs has same dimension? Okay. So the same dimensions pair are given. So you have to find out the correct one. First option is angular momentum and Planck's constant h. So for angular momentum we write it as P into R, product of linear momentum into radius. So the linear momentum can be written as product of mass into velocity into R. So what is the dimension for mass? Capital M. For velocity, the dimensional formula is L T raised to minus 1, and for radius it is nothing but L. So we get that M L square T raised to minus 1. So this is the dimensional formula for angular momentum. For Planck's constant h, Planck's constant is given by h is equals to E by mu, where E is the energy, mu is the frequency. The dimensional formula for energy is ml square T raised to minus 2, and mu frequency is given by T raised to minus 1. So what it becomes on simplification? ml square T raised to, here it is minus 2 and in the denominator it is minus 1. If we take to the numerator, minus 2 plus 1, that is minus 1. So the Planck's constant is having a dimensional formula of ml square T raised to minus 2, and angular momentum is also having a dimensional formula of ml square T raised to minus 1. So the correct answer is angular momentum and Planck's constant are having the same dimensions. If P, Q, R are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? There are three quantities P, Q, R. Say the dimension of all the quantities are equals to D. Let us consider it as D. Now in the four options given, so which one is not meaningful? We have to find out. Say let us take first one. First one is P minus Q divided by R. Substitute here dimensions D minus T divided by R. This becomes meaningless. So this ratio doesn't have any meaning. So the correct answer is option A. You can also try with the option C, D and B. Since you do not have time, you have to find the correct answer. Next one, the dimensions of specific heat are. The specific heat is given by S. It is defined as ratio of Q divided by M into theta, where M is the mass, Q is the heat energy divided by M is the mass, and this theta is nothing but the temperature. Okay, so the specific heat is defined as Q divided by M into theta, where Q is the thermal energy or heat energy. So for energy, the dimensional formula is ml square T raised to minus 2 divided by mass is M, and So the dimensional formula for theta is k. So these are the dimensions for the three terms. So simplify this. M dimension get cancels. So the remaining is L square T raised to minus 2 K raised to minus 1. Okay. This is the dimensional formula for specific heat. So the correct answer is option D. L square T raised to minus 2 K raised to minus 1 is the dimension for specific heat. Similarly, you have to find the dimensions of a torque. So the torque is defined as, the formula for torque is force into perpendicular distance. Okay, force into distance, F into R. So the dimensional formula for force is ml T raised to minus 2 into the distance is given by L. So on simplification we get ml square T raised to minus 2. This is the dimensional formula for torque. So the option B is the right answer. Next one, the ratio of the dimensions of Planck's constant and that of the moment of inertia is the dimensions of. So there is a physical quantity, say x. This physical quantity, it is the ratio of Planck's constant and moment of inertia. Already we know that nh by 2 pi is equals to I omega. We have to substitute h value. H is equals to 2 pi I omega divided by n. So substitute here, h is equals to 2 pi I omega divided by n whole divided by I. What it becomes? 2 pi I omega whole divided by n into I. So I get cancels. Remaining is x is equals to 2 pi omega divided by n. 2 pi n are constant values. They do not have any dimension. So the remaining is omega. So this x physical quantity is having the dimensions of omega frequency, that is T raised to minus 1. Okay, frequency. The option B is the correct answer. Identify the pair whose dimensions are equal. Okay, there are 4 pairs. Here we have to identify the pair which has equal dimensions. So let us try the first option. Torque is equals to force into distance. Force is nothing but ml T raised to minus 2 into distance is L. This becomes ml square T raised to minus 2. And work is nothing but energy. So we remember the formula for energy. What is the dimensional formula? ml square T raised to minus 2. So it means that the torque and energy are having the same dimensional formula. So the correct pair which is having equal dimensions is torque and energy. So option A is the correct answer. The physical quantities not having same dimensions are. Now we have solved the dimensional formula for same quantities. Now we have to find out the different dimensions. Okay, so already we have solved that torque and work are having equal dimensions. Now we have to find the second one, that is momentum and Planck's constant. Let us find out for momentum. It is defined as m into v, product of mass and velocity. Dimension for mass is m and for velocity it is L T raised to minus 1. So the momentum is having dimensional formula m L T raised to minus 1. Now Planck's constant. So let us find out. E is equals to h nu. So h becomes E by nu. Energy is having dimensions of m L square T raised to minus 2. This mu is having T raised to minus 1. So this becomes m L square T raised to minus 1. The dimension of momentum is m L T raised to minus 1 and Planck's constant is having ml square t raised to minus 1. So these two are having as different dimensions, momentum and Planck's constant. So the answer is option B, which are having different dimensions. Which one of the following represents the correct dimensions of the coefficient of viscosity? Okay, now we have to find the dimension of coefficient of viscosity. You have learned it in the Stokes law. Okay, what does the Stokes law says? Stokes law is given as F is equals to 6 pi eta r V. Here eta nothing but coefficient of viscosity. Define the eta, what it becomes? F divided by 6 pi r V. Here V is nothing but terminal velocity. So the force is having dimensions m l t raised to minus 2 whole divided by 6 pi is constant, leave it. R is the radius or means length, so it is having dimensions of L, and velocity is having L t raised to minus 1. So L get cancels, remaining m L raised to minus 1 t raised to minus 1, isn't it? So this is the dimensional formula for eta. Okay, so the correct answer is option A. The density of a material in a CGS system is 8 gram per centimeter cube. In a system of unit in which unit of length is 5 centimeter and unit of mass is 20 gram. So the density of material is, we will find a shortcut for this. So the shortcut is N1 U1 is equals to N2 U2 for the conversion of units. Let us take N2 is equals to N1 U1 divided by U2. N1 U1 N2 U2 means these are the units in two different systems. In the given data, the density is 8. So here N is the density, N1 is the first unit and N2 U2 is the second system of unit. So in the first system of unit, the density of the material is 8 gram per centimeter cube. In the second system, the length is increased by 5 centimeter and mass is increased by 20 gram. So now we have to find the density of material. So N1 is the density of having 8 value. Now we have to find the value of N2. So N2 becomes 8 into U1 by U2 is nothing but it is the ratio of mass M1 by M2 and the length L2 by L1 cube. This U1 is nothing but mass by volume. Now simplify the terms. In M1 the value is as it is. M2 means mass is increased by 20 times the M1. So the M2 value becomes 20 M1 and L2 is increased by 5 centimeter of L1. So where L2 becomes 5 L1 and M2 becomes 20 M1. So L1 get cancels, M1 get cancels. Simplify this, you will get N2 is equals to 8 into 1 by 20 into 5 cube. On simplification, you will get the answer 50. So the option C is the right answer. The dimensional formula for magnetic flux is, we have to determine the dimensional formula for magnetic flux. Magnetic flux is given by dimension of voltage into dimension of time. This is the formula for magnetic flux. Now substitute the dimension of voltage. So the dimensional formula for voltage is m L square t raised to minus 3 a raised to minus 1 into the dimension of time is t. So simplify this, you will get the answer m L square t raised to minus 2 a raised to minus 1. The option A is the correct answer. If force F, length L and time T are assumed to be fundamental units, then the dimensional formula of the mass will be F, L, T. These are assumed as fundamental units. Now we have to find the dimensional formula in terms of F, L and T. Now let us consider that this dimension of M is dependent on F raised to A, L raised to B, T raised to C. So the powers given to the quantity are nothing but the dimensions, isn't it? Substitute the dimensions of F, L and T. The dimensional formula for force is mLt raised to minus 2 whole raised to A, and L is having power B and T raised to C. So club the powers A, B and C. So here m raised to A, one term, and L raised to A, there is a one term here, and L raised to B is one term. So this becomes L raised to A plus B. Base is same and the powers are added. Now third one, T raised to minus 2A plus C. So these are the dimensions of M, L and T. Now equate the powers A plus B to minus 2A plus C. Equate the powers to this LHS. So the mass is having here dimension 1. So it means that here m raised to A is equals to m raised to 1. It means A value becomes equals to 1. A is equals to 1. Now A plus B equals to 0 because there is no L term here, isn't it? It means L raised to 0 and T is also 0. Now L raised to A plus B is there. Now it becomes A plus B equals to 0. So A is 1. So B value becomes minus 1. And minus 2A plus C equals to 0. Minus 2 plus C equals to 0. A value is 1. C equals to 2. Substitute the powers in this equation. Okay. Equation number 1. Substitute here what it becomes. M is equals to F raised to 1. L raised to minus 1. And T raised to plus 2. Okay. So F raised to 1, L raised to minus 1, T raised to 2. So in the option, which one is the answer? Option A is the right answer. Which one of the following represents the correct dimensions of the gravitational constant? We have to find the dimensional formula for gravitational constant. So what is the formula for gravitation? Law of gravitation states that F is equals to G m1 m2 divided by r square. Okay. So m1 m2 are the masses, r is the distance between them, G is the gravitational constant, F is the gravitational force. Now G becomes F r square divided by m1 m2, isn't it? So substitute the dimensions of F r square m1 and m2, you will get the dimensional formula for gravitational constant. So the force gravitational constant is m L T raised to minus 2. Force is given by this formula, and r is the distance. So r is having the dimensions of length. So r square is there, it becomes L square divided by m1 m2, m1 m2. Okay, so this m get cancels and here L raised to 1 is there. This is L square is there. Now the final answer is m raised to minus 1 because we have a m here. M raised to minus 1, L raised to 3, T raised to minus 2, isn't it? So simplifying, we get m raised to minus 1, L cube, T raised to minus 3. So the option A is the correct answer. The dimensions of magnetic field in M, L, T and C is given as, where C is the coulomb. Now we have to consider M, L, T and C as fundamental units. Okay, these are the fundamental units where C is the coulomb. Now we have to find the dimension of magnetic field. So the expression for magnetic force field is F is equals to QVB, where F is the magnetic force, Q is the charge, V is the velocity and B is the magnetic field. So B becomes F divided by QV, isn't it? Now substitute the dimensions. F means M, L, T raised to minus 2. Charge is having the dimensions of coulomb and velocity is L, T raised to minus 1. Okay, on simplification we get that. So this L get cancels, remaining M, C raised to minus 1 and T raised to minus 2 plus 1 becomes minus 1. So this is the dimensional formula for magnetic field. So option C is the correct answer. The dimensions of coefficient of self-inductance. Now we have to find the coefficient of self-inductance. So the formula for self-inductance is given as U is equals to 1 by 2 L I square. So here U is the energy stored, L is the self-inductance, I is the electric current. So what we have to derive? We have to derive the dimensions for L. So L becomes, L is equals to 2I divided by I square, isn't it? Now energy stored is nothing but this U. So dimensions for energy is ml square T raised to minus 2 whole divided by I square means current, which is having dimensions of A. It becomes A square. Now simplify this, you will get m L square T raised to minus 2 A raised to minus 2. So this is the dimensional formula for self-inductance. So the option A is the correct answer. The division of energy by time is X. The dimensional formula of X is same as that of. So it is given that X is the division of energy and time. What will be the dimensional formula for this X? So the energy is having dimensions of ml square T raised to minus 2. Time is having the dimension of T. So on simplification we get ml square T raised to minus 3, isn't it? So this is the dimension of X. Now which one is having this dimension? Let us see. The momentum is, first option, momentum is having the dimensional formula ml t raised to minus 1. So this is not the answer. Next, B, power. Power is nothing but energy by time. So on simplification we get ml square t raised to minus 2. So this is nothing but the answer, power. So power is having the dimension of ml square t raised to minus 3. The solar constant is defined as the energy incident per unit area per second. The dimensional formula for solar constant is the solar constant S is given by energy per unit area per second. Now substitute the dimensions. ml square t raised to minus 2 is the dimension of energy. Area is having L square and second is having the dimension t. Simplify this. L square get cancelled. So you will get ml raised to 0 t raised to minus 3. Okay. So option D is the right answer. Which of the following is a dimensional constant? We have to determine the dimensional constant here in the 4 options. So what is the dimensional constant? So a constant having dimensions and this value remains constant, as the name says. It is having a constant value and it possesses a dimensional formula. Okay. Which one of these is a dimensional constant? So let us see. Here refractive index nothing but it is the ratio of sin I by sin R, isn't it? So it is the ratio of similar quantities. So this is a dimensionless. This refractive index is dimensionless. It doesn't possess any kind of dimensions. Second one, dielectric constant. So what is dielectric constant? So dielectric constant is nothing but it is the ratio of relative permittivity to the absolute permittivity. So it is also dimensionless because these two are having same dimensions. They get cancelled with each other. So dielectric constant is also dimensionless. Next, relative density. So already we know that the relative density is the density of material compared with the density of water. So density it is the ratio of similar quantities get cancelled. So this is also dimensionless. So all the three values are dimensionless. So these cannot be the answer. So the right answer is gravitational constant. So the gravitational constant is having the dimensional formula ml raised to minus 1 t raised to minus 3. So answer D is the right answer.